Hello everybody. Today we'll start with the chapter 7, Congruence of Triangles. It's a very interesting chapter. But here, before we start with the chapter, we need to know about the meaning of the word congruent. So what do you understand by congruent? Suppose if there are any two objects, you must have seen various objects, like if I say a coin, and if I take a similar coin which is exactly of the same shape and same size, then I say that they are two congruent coins here. Similarly, if I take any two biscuits which are of the same shape or same size, then I'll call that these two biscuits are exactly congruent. Similarly, if you take any two stamps, then if you put one stamp over the other, that means when you put one thing over the other in such a manner that it completely superimposes the first one, then we call the two things as congruent things or congruent objects. Now, is it necessary that they can be only like a coin, a biscuit, or any stamp or something like that? No, it can be a line segment, there can be angles also. But before we go into the depth of this topic, let us first see what do you understand by the word congruent over here. So here we have noticed that in these two figures, in these three figures, that if you superimpose the first one over the second or the second one over the first one, you'll find that you'll be able to see only one of the object. That means we can now conclude with the thing that the relation of two objects when being congruent is called as congruence. So what do you understand by congruent things here? If two things are exactly of the same shape and same size, we call those objects as congruent objects. Now what if their size is same but the shape is different? Or what if the shape is different but the size is same? We'll discuss it in detail. So here we conclude one thing, that congruent objects are exactly of the same shape and same size. Now what if there are two plane figures like these, the figure 1 and figure 2, are they congruent to each other? So if we have to check it, what we can do? Now since they are plane figures and we cannot put one over the other, so what we can do? We can trace one object and then with the tracing paper we can check whether they are exactly of the same shape or the same size. And if they are exactly of same shape and size, we say that they are congruent. And here we are introducing the symbol of congruent, that is this symbol, an equal to sign with a wave over it. So here we can say the symbol for congruence is equal to sign with a wave over it. So if two objects are exactly of the same shape and size, we represent them as the figure 1 is congruent to figure 2, as it is written over here. So this is about the congruence of any two objects. They may be plane figures, they may be 3D objects also. It's not necessary that they can be plane, like two circles are congruent if their radii are equal, right? Similarly, can we compare line segments also? Yes, if a line segment is given to you like AB and one more line segment is there, say CD. And how can we find out whether they are congruent or not? You are familiar with the word equal, right? So it is same thing as here. If you superimpose one line over the other and then you find that they are exactly of the same size, that means they are exactly of equal length, then they are said to be as congruent lines. So in other words, we can say the point A should fall on the point C, or C should fall on the point A, and the point B should fall on the line on the point D, and D should fall on the point B. That means the length of AB is exactly the same or exactly equal to the length of the line segment CD. So they are congruent line segments, which we in general call them as equal line segments. Now next to this is, what about if there are angles? Can two angles also be congruent? Yes, as we have done for line segments, that if they are of equal length, then they are congruent. Similarly, for angles, we can say if they are of equal measure, then they will be called as congruent angles. So here we can say if we put one angle over the other angle, right, in such a way that their measures are exactly the same, as you can see here, ray 1 and ray 2, they completely coincide with each other. So we can say the two angles will be exactly equal in measure, or they are called as congruent angles. Suppose first angle made between these two rays, if it is 60 degree, and the angle made by the next two rays is also 60 degree, we call them as congruent angles. Now let us move on to the next segment, that is congruence of triangles, and it's a very important topic as well, and a very interesting one here. So when can you say two triangles are congruent to each other? If we see that if I put one triangle over the other and I found that they are of exactly same shape and size, then the triangles are said to be as congruent triangles. But in this also, how can I find whether the sides are equal or the angles are equal? Yes, in a triangle there are 6 parts. 3 are the angles and 3 are the sides given here. So we say if one side of one triangle is respectively equal to one side of another triangle, similarly the second side equal to the second side and the third side equal to the third side, and all the angles respectively are equal to the corresponding angles of the second triangle, then we say that the triangles are congruent to each other. But we'll study it in detail over here. So here we can see that when we put one triangle over the other triangle, their vertex should superimpose each other. So now let's see a triangle ABC, and let's take one more triangle, that is PQR. So here we have seen if a triangle completely overlaps with the second triangle, that means, are you able to see the PQR triangle here? No. When ABC completely superimposes, we see they are exactly of same shape and same size. So here we can see in triangle ABC and triangle PQR, we say that triangle ABC is congruent to triangle PQR, because when one is put over the other, it completely overlaps the previous one, and we find them both as one. That means they are exactly of same shape and size. So they are congruent here. But how we can elaborate it? So for this, let's again take the triangle ABC and the triangle PQR. So after superimposing, what we have observed, let's see it in detail over here. The side BC and the side QR completely overlaps, and here on comparing the vertices, we find that the vertex A is completely overlapping the vertex P. Similarly, vertex B completely overlaps the vertex Q, and the vertex C completely overlaps the vertex R. It exactly fall on it. So here we can see this thing, that AB is also equals to PQ, BC side is equal to QR because it completely overlapped it, and the side AC also overlapped the side PR. So here we can say the corresponding sides are equal. One side of first triangle is equal to one side of the second triangle. Second side is equal to the second side of the another triangle, and the third side of first triangle is equal to respective third side of the second triangle. And this is very important, that which part is overlapping which part of the second triangle, because these will represent the name of the congruent triangles based on this, because here the order is the most important thing and we have to check the order while we write the name of the congruent triangles. So here let us proceed. In this also we have observed that angle A is equal to angle P, angle B is equal to angle Q, and angle C is equal to angle R. So from this we can see there are 3 sides and 3 angles. That means in all there are 6 corresponding parts in 2 congruent triangles. Now here we can see, after observing this thing, that there are 6 parts over here. Now out of these 6 parts we need to choose 3 parts to find whether the triangle are congruent or not. Is it like any side is given to you equal to any other side, or any angle is given to any other angle? Will the triangles be congruent in these cases or not? Let us study it in more detail. But from this we can see that triangle ABC and triangle PQR are congruent to each other. Let's proceed further. Now, what are the various criteria for congruence of triangles? Obviously, there should be certain rules from which we can check without actually superimposing the triangles one over the other, that whether they are congruent or not. And the first criteria is SSS criteria. Here S stands for side. So, side, side, side. That means if in one triangle all the three sides are given, then will the second triangle having the same length of the sides, will it be congruent to the second triangle? So let's check it in detail. For this, suppose if I have been given only one side, 5.5 centimeter, right? So what type of triangles I can frame only if one side is known to me? I can frame an obtuse angled triangle. I can also frame using the same 5.5 centimeter a right angled triangle, and I can also frame an acute angled triangle. For the second triangle, if just one side is known to me, I have three different options. But now I have to check that out of these three, will any of these overlap with the previous triangle which was already given to me? No, because from this I cannot judge exactly which angle is equal to which angle, and if I superimpose them, will they be exactly of same shape or same size? In this case, the shapes are even different, right? So there should be some more criteria which must be given to us, because if we just know one side, we cannot judge whether the triangles are congruent or not. So let's move on to the second side. Suppose the second side is also known to me. Now, first side is given 5.5, second side is known to me 3.4. But with these two options also I can frame many triangles, like 3 triangles at least. I can have 3.4 as a right angled triangle, I can have 3.4 obtuse angled triangle, or I can have an acute angled triangle with these two sides known to me. But still, I don't know which of the triangle is exactly of the same shape and size which was already given to me. For this, now it's a very important thing to note here. If the third side is also known to me now, will I be able to get the same triangle which was known to me already? From these two, I cannot find the congruent shape, the congruent triangle to this. So, exact copy I cannot get, right? Of course, there may be same shape, but size may be different, right? Or if there is same size, the shape is different, because see, the size are equal, 5.5 and 3.4, but this is an obtuse angle triangle, and the one given to me in the question was acute angled triangle, right? So here we see from these two things, if the third side is also known to me. Now, if the length of AC is also given to me, that is 5, how many such sets of triangles are possible? Obviously, with these 3 lines given to me, with these measures of the lines given to me, I'll get only one such triangle. And this particular triangle will be congruent to the one which was already known to me, which was already given to me. So, if a triangle ABC is given and another triangle PQR is given, and if all the 3 sides of the triangles are known to me, I can say that the triangles are congruent by side, side, side criteria. That means, according to this condition, if 3 sides of one triangle is equal or respectively equal to the 3 sides of another triangle, the triangles are said to be congruent by side, side, side criteria. So this is one criteria. Are there any other criteria also? Let us check it. One more criteria, suppose if 2 sides and 1 angle is known to me. Now, we relate it to SAS criteria. But here also a very important thing is to be noticed, that the angle that is given to us, it is included between the 2 sides. It cannot be any angle. There is a specific property for the triangles to follow SAS criteria. That is, the angle should be included between the 2 sides. Let us study in more detail. Now, suppose we have a triangle ABC with one side given as 5.5 centimeter, and if I give you one angle as 65 degrees, what are the possibilities in which you can draw this triangle? Is it the sufficient condition to draw a triangle with this? If simply I just draw a line segment of 5.5 and then I just draw an angle of 65 degree, the ray forming the angle can be of infinite length, any length, whatever suits you, you can take that. That means in this case the size is not fixed for the triangle. So this is an insufficient information provided to us. So we need one more information for this, right? Because see, if I give 5.5 and 65 degrees, I can get a right angled triangle, or I can even draw an acute angled triangle with this, and even I can draw an obtuse angled triangle with this measurement. So this particular information is insufficient. But what if I know one more thing, that is one more side, maybe this side, or what if I know this side, in which way the triangles can be congruent. Suppose that if I now add something more information here, in this case, let me take one more side, that is 3.4 centimeter. Okay, let me try with this. So here, I'll first draw a line segment of 5.5 centimeter. To this line segment, I'll draw an angle of 65 degrees. And now, since the length is given to me as 3.4, so from C I'll get a point which is 3.4 centimeter distance from the point C, and then I can simply join the 2 points. So here what we have used, very importantly, we have used a side, then we have framed an angle, and then we have again chosen the side which is equal to this. So we have used SAS, that is side, angle, side. Here the angle is included between the two line segments which is known to us. It cannot be any side, it should be those two sides which are known to me, and the angle should be framed between those two sides of the triangle only. So here we can say, now we can name the criteria as SAS, that is side, angle, side. So first criteria by which we can find the triangles are congruent was SSS criteria, that is side, side, side criteria. The second one is SAS criteria, that is side, angle, side criteria. Are there any other criterias also? So yes, but before this, let's conclude this SAS, that if two sides and the included angle between the two sides of one triangle is respectively equal to the included angle and the two sides which are including the angle to them, then they are congruent to each other. So one more criteria now, next after SAS, what? What if two angles are known to us and a side is there? In that case also, will the triangles be congruent? Let's check that. Suppose that in now a new triangle ABC and triangle PQR, what is known to us? Say the side BC and the side QR of the length 5 centimeter is already known to us, and angle B and angle Q measures 45 degree, and angle C and angle R respectively are equal to 55 degrees. So will the two triangles be congruent? That means if I put one triangle over the other, will I find that the two triangles are of exactly same shape and size? Yes, in this case obviously the triangles will be congruent to each other, because the side here is included between the two angles. See, if I superimpose triangle ABC on the triangle DEF, will I get the two triangles congruent? Yes, you can check. The vertex B will fall over the vertex E. Similarly, vertex A will fall over the vertex D, and vertex C will fall over the vertex F. So we can see here that if two angles are known to us and the side which is included between the two angles, they will be congruent to each other. But what if instead of giving the side BC equals to EF, if I have been given, say, the side BC equals to the side DF, still will the two triangles be congruent to each other? So let's check it. Suppose if two triangles are there, triangle A, B, C, in which it is given that angle B of second triangle PQR. If I say angle B is equal to angle Q and angle C is equal to angle R and the side BC is equal to PR, will the two triangles be congruent to each other? No. In this case, they are not congruent. Reason being, the side which is there included in the triangle PQR, it is not the one which is included between the two angles. If it is ASA congruence, then the side should be included in between the two angles. That means it should be sandwiched between the two angles. So here we can see the angle with the side which is sandwiched between the angle Q and the angle R will be QR. So here if I am comparing angle B and angle C, then I have to compare the side BC to the side QR of the another triangle. So in this particular case, the triangles will not be congruent. So it's not necessary whenever any two angles are given and whenever one side is given, the triangle will be congruent. They may be congruent, they may not be congruent. But of course, whenever two angles and the included side is given equal to the respective angles and the included side of the second triangle, in that case, the triangles will always be congruent to each other. So I hope ASA property is also clear to you. Let us now move on to the next property, that is RHS congruence criteria. Now here, this is also a very interesting one. RHS, in this, R stands for right angle, H stands for hypotenuse and S stands for the side. Now in this, as it is very clear that it is applicable only in case of right angled triangle, because first criteria is right angle. So when there are two right angled triangles, can we apply RHS in all the such triangles? Not necessary, but yes, if in two right angle triangles their hypotenuse are equal and also one of the side of one triangle is equal to one side of the another triangle, we say that the triangles are congruent to each other. For example, if we see from the picture, we find in this case AC is equal to PR. They are hypotenuse. Why they are hypotenuse? Because they are opposite to the right angle. That means here in this case, if angle B is 90 degree, we find that the side opposite to the right angle is hypotenuse. So AC is the hypotenuse in this case, and since angle Q is 90 degree, so PR is the hypotenuse in the second triangle. So AC and PR are equal to each other. Also, one more side, BC is given equal to the side QR. Right? So we can see there is a right angle, there is a hypotenuse and there is a side given. And here also respective right angle, hypotenuse and one side. But in this case, we can also say instead of QR, if PQ is given, then also the triangle will be congruent to each other. Because side means any one side. It may be that BC is equal to RQ, or it may be that the side BC is equal to PQ given. Any one side may be given equal to the any one side of second triangle. Or we can also say the side AB might be equal to QR. In this case, then we can say still the triangles will be congruent by RHS congruence rule. So here I think this part is very clear. Let's take it with an example also. In two triangles ABC and the triangle PQR, if the length of BC is given as 8 units and the length of QR is also given as 8 units, also the length of AC is 10 unit and PR is 10 units, we see if we superimpose the two triangles, we find them as congruent, because here also the two triangles will be exactly of same shape and same size. So we say that triangle ABC and triangle PQR, the side BC is equal to QR, angle ABC is equal to angle PQR, because they are 90 degree each, and AC is equal to PR. AC and PR are equal because they are the hypotenuse. So we say that there is a right angle which are equal, there is a hypotenuse and there is a side given equal. So triangles will be congruent by RHS property. So I hope this topic of congruence is very clear to you. Let us discuss in detail with some more basic examples.
To watch the complete video, download the Upbind educational app from Play Store and App Store.